if you come to here, suppose these are the corners of a square A, B, C, D, E. Here you said the distance from center to any corner is L by root 2. Okay, now I'm asking, is this diagonal the angular bisector of the angle at a corner? Oh, angular bisector. Angular bisector means, will you say this angle is how much? Means DAB. Do you know that angle here? Someone is typing there. Okay, we'll see what is the answer. How much is that? Oh my goodness. It is a simple one. What will be the total angle here at a corner in a square or rectangle anywhere? Yes, exactly. Narsimulu. Total angle is 90 degrees. And this is the angular bisector. Yeah. Angular bisector means exactly half of the angle. 90 by 2. Yes, yes. Half of it is 45. That's what I asked. Okay, right. It is 45 degrees. And here I see the point. The diagonal is an angular bisector. And will you please tell how much is the angle between the two diagonals taken here in a square? Angle between these two lines, blue line and the other line, angle between these two. Okay, it's simple. You're responding very slowly here. Okay, no problem. Angle between the two vectors, shall I say it as 90 degrees? Yes, exactly, Akhilesh, 90 degrees. Means here, shall I write another point related to here the diagonals? The diagonals are perpendicular to each other. Is it right? Why? Because you said the angle between the two diagonals is 90 degrees. So shall I say diagonals are perpendicular to each other? Okay, yes. And next one, yes, yes. And next one I write here, from center, since it is the center to any vertex, the distance will be same. Means what I'm saying here is CA is equals to, shall I write it as CB, which is equals to CD, that equals to CE, that equals to L by root 2, what you said initially. Yes, very good. These are the points what you have to remember related to whom? The square. Okay, do you have any doubt here regarding these points? What I pointed out? Yes, do you have any doubts? No, right. I think you know all these points in your lower standard. Yes, exactly. Right. Come to here, same kind of points I'm going to write for the rectangle. Okay, right. Come to here, in this case of rectangle. Of course, the diagram itself, it says it is a square. No need to write. But for convenience, I'm writing here, it is rectangle. Yes. Here in the rectangle, first point, will you say the angle here means the diagonal is an angular bisector or not in case of a rectangle. Oh, every day I'm forgetting Nana. Andrew, sure. Today I will try to make it possible. Okay, and who is this? Ashrit. Ashrit Vassa. Sure now. Yes. Is this 45 degrees? You are saying? Sure. Okay. Okay. Come to here. You are okay. Sujata is saying no, all others are saying yes. Okay, right? And yeah, we will check why they are saying yes. Okay, I take that angle as theta1, the other angle as theta2. No, Akhilesh, how can you say that is 30 degrees? Once you check here, yes, this is theta2. Okay, come here, shall I say, like A, B, of course, center every time I am taking it as C, so better I take it as C, A, B, C, D, E. For your convenience, I am saying here, from the triangle ADB, once you check there, sine theta 1, or better for your convenience, tan theta 1. This one you can understand very easily. Tan theta 1, how much you save from this triangle? Shall I say opposite side by adjacent side? Opposite side is B, by adjacent side is L. Any mistake here? Tan theta 1? I think it is correct only. Okay. And in the same way, look at the other triangle. Yes. In the look at the other triangle here, AED. Correct only. Thank you, Lalit. Yes. Tan theta 2. In the same way, tan theta 2 for this angle, opposite side is L, adjacent side is the breadth. Yes. Here L by B. Look at, are these two equal? B by L and L by B? No, I think. Yes. If they are not equal, how can you say that two angles are equal? Theta 1 is not equal to theta 2? Surely. Yes. Theta 1 is not equal to theta 2 means here I say out of length and breadth in the diagram, given diagram, breadth is appeared to be the shorter one and length is appeared to be the longer one. So breadth is shorter means here numerator is less. Numerator is less in the first one means the angle will be less. Since the numerator is less, angle is less means just to get some proper data, Nana. Why? Because yesterday only I told, in any triangle, the angle what we are using depends upon the information he gave. Gangishetty. Okay. Here, suppose this is the angle theta, and I know, suppose the opposite side and the adjacent side, immediately I will go to tan or cot. Okay. Depending upon the information available in your pocket. Okay, in your pocket, look at here in the triangle, you know the opposite side breadth, you know the adjacent side length. Yeah, that's why I took the tan. If I know the hypotenuse, I will go to either sine or cos. Yeah, depending upon the information. Yesterday only I told now. Okay, right. Then, yeah. Okay. It is your surname. Na? Usually I call the students with their surnames only. Okay, you can understand later. Okay, nothing to worry here, Gayatri. Yeah. Okay, right. Theta 1 is not equal to theta 2, right? And that too here, breadth is small and length is big. So breadth is small means in the ratio, I will get theta 1 value less. So from the two informations, what I wrote in the above two steps, shall I conclude that theta 1 is less than theta 2? Okay. You came across these 2 points, understood? Yes. Good. So here I can't say the angles are exactly 45 and 45 like in this figure. Whereas here this is the angular bisector. That's why exactly I told here it is 45 degrees and the other one is also 45 degrees. Okay, come to here, they are not equal. Okay, one thing I can say, what depending upon the angle opposite to the shorter side is less, the angle opposite to the longer side is more. That information I can say what I wrote here. Okay, so shall I conclude from this above explanation here? The diagonal is not an angular bisector. Will you accept my point here? Ah, yes, very good, very good. Okay, then come to here. Yes, good. Come to here. This is the other diagonal I'm taking. Okay, and look at here. If you see there, in this case, the two diagonals are perpendicular to each other. But in the diagram only it is saying that, yes, this is appear like acute angle and it is appear like obtuse angle. You only check over there. Okay, this is acute, that is obtuse. This is less than 90, that is more than 90. What do you say? Yes or no? Just by seeing, yeah, sometimes we have to respond very quickly. Just by seeing the cover, we have to judge. Okay, no need to open the book. Is it clear? Yeah, just by seeing the cover, just by seeing the diagram here, we have to judge what I'm saying, it is correct or wrong. Okay, good. Okay, be sharp, respond quickly. Okay, right. So here I'm saying these two angles, one is obtuse, yes, another is acute. That's why this is less than 90, that is more than 90, means here the angle between the two diagonals is not equal to 90. Okay, that's why shall I write here the point like the diagonals are not perpendicular to each other. Okay, but I say C is the center, they bisect at C. Yes, bisect. Bisect means the last point is valid. CA is equal to, yeah, exactly. They bisect. That's why, since they are bisecting each other, CE is equals to, I write CD equals to CB equals to CA equals to, I don't know whether I gave the point the length of diagonal yesterday or not. Anyone remember the length of diagonal rectangle? Okay. Even though if it is not given, why don't you say the length of AD from the triangle ABD, hypotenuse? Yeah, square root of, I think you can say using a Pythagoras principle, square root of side square plus side square. So here AD is equals to AB square plus BD square. That is L square plus B square. Is it right? Yeah, AD square equals AB square plus BD square. Akhilesh, yes, exactly. Okay. We should respond very quickly. Like there should not be a sip between lip and cup. Okay. If there is a sip between cup and lip, I will write many points in the middle. Okay, Akhilesh? Right. That much quickly we have to respond. Right. Here. Okay. Then here CE is equals to CD, that equals to CB equals to, that is CA equals to half of the length of the diagonal, that is AD by 2. Okay. Right. Now I say finally, in both square and rectangle, in both, I say they mean, sorry, again you may ask, who are those, sir? The diagonals. Okay, bisect each other. Okay, but in one case they are perpendicular to each other, in another case they are not perpendicular to each other. Okay, the point that you have to remember. Okay, good. These are the points related to square and a rectangle. Okay, what you have to remember. Yes, yes, good. Then after completing the rectangle and square, yes, good, good. After completing this, yes, you have to come to know about like the three-dimensional bodies, 3D bodies. 3D bodies means here till now I discussed who, ring, disc, square, and rectangle. What are required? Still many are there. Parallelogram, trapezium, here and rhombus. Many are there, but we use them very rarely. Okay, that's why I'm not interested to say about those things which are required and frequently we use in our physics. Those things only I dump here as the points in my mathematical tools. Okay, right. Filtering many points there, which are unnecessary. Just filter them. That's it. Okay. Don't try to catch the scrap. Try to catch the stream. Okay. Right. That is your wish, Nana Aishwarya. Okay. Maintaining two different books for both the tracks of physics or not, that is your wish. Right. Coming to here. Now we are trying to catch the not the scrap, but the cream. In the cream, next points we are going to discuss here. Okay. In three-dimensional bodies, when you come to three-dimensional bodies, in the three dimension, what he says, many bodies are there again. In them, the required things again I'm taking. What are, sir? One is a sphere. Okay. So in case of sphere, yes, in case of sphere, what you're asking, sir? Yeah, come to here. I'm asking, what will be, I think this one anybody can say, volume here. I think all of you know this. Gangi Shetty, actually, sorry to say, it is a stupid question. Why mathematics is involved in physics? Mathematics was developed to use that in physics. Keep in mind. Okay. Actually, mathematics is part of physics. To use the things, data there, we developed, means the physics scientists developed mathematics. Okay. Simple. Mathematics is just like a daughter of physics. Physics is the mother of all subjects. Okay. Don't ask who is the father. Here volume is equals to 4 by 3 pi. Someone posted here, Akhilesh, what is this, Nana? 2 by 3 or 4 by 3? Akhilesh? Yes. Next you corrected it. 4 by 3. Very good. 4 by 3 pi r cube. Yes, exactly, Lalit. 4 by 3 pi r cube. This is volume. I don't know why, because very few responded here. So I think you have to remember, it is alarming actually. All right. Volume equals to 4 by 3 pi r cube. Keep in mind. Number 1. And here, the second one I am asking, I don't know whether you remembered it from your lowest standards or not. What will be the surface area of sphere? Wow, nice. Akhilesh again responded. Okay, Akhilesh is responding very quickly here. Very good, Akhilesh. Keep it up. Yeah. Redigaru, 4 pi r square. Yeah. Now this time Gangi Shetty also responded. Yes. 4 pi r square. Very good. This is the surface area. Okay. In case of a sphere. And this point, I think very few remembered. I believe. Suppose this is a sphere. And in this sphere, I select a part like this. This is actually a part of sphere. Okay. Better I take here like this. Yeah. This is what I say. Part of sphere. Okay. This is not hemisphere. Keep in mind, hemisphere means half. Part of sphere, I took up to here only. This is part of sphere. I selected. This part of sphere, you only see now, is it hemisphere? Hemisphere means I think you have to take up to the center. Is the shaded portion hemisphere or not? I think this is not hemisphere. Not hemisphere, I think. Hemisphere means till here, no. This is hemisphere. This part is hemisphere. It is not hemisphere, right? This is just a part of sphere, not exactly half. Okay. So in this case, if it is not hemisphere, part of sphere, okay, how to calculate its area? Okay. For that, very simple, I say, okay, this hemisphere has, suppose, the center somewhere here. Sorry, part of sphere, not hemisphere, has the center somewhere here, and here from the center to any point on the surface, if you draw a line, it is the radius. theta by 360 into pi r square. Akhilesh, is it a three-dimensional diagram or four-dimensional diagram? Sorry, two-dimensional diagram. It is, I think, 3D. Yeah, 3D, not 2D. That's why I'm saying here the angle in three-dimensional figures, we measure the angle. What I'm saying here is, yes, is not the plane angle. Okay, means the total angle in case of circle or any other two-dimensional bodies, the angle at the center is 360 degrees. Okay, whereas in case of three-dimensional bodies, we measure the angle at the center, which is called as not plane angle, it is called as solid angle. Plane angle usually we measure in the units of radian, but solid angle is measured in the units of steradian. Keep in mind. Okay, so the solid angle here, 3D, yes, in 3D, solid angle. Okay, represented with the letter omega, like this, like how you put the symbol for resistance in your lower standards. Am I right? Am I right? Resistance of a wire, suppose if I say 10 ohms, we represent like this. Yes, that omega only I'm taking here. Okay, so that omega I'm writing there. Ohm, like this is omega. Now the symbol is. Okay, right, solid angle, which is omega, at the center of a full sphere. Okay, is equals to, we say that full angle is not 2 pi, 4 pi steradian. Not radian, steradian, 4 pi steradian. Okay. Now I think you can say, if I say the solid angle here as omega, using your common sense only, Mr. Akhilesh, you said in case of two-dimensional diagram, area equals to theta by 360 degrees into pi r square. Use the same common sense here. At the center, it is not 360 degrees, 4 pi steradian. Now for the part of sphere, the angle at the center is not theta, that is omega. Into area is not pi r square, 4 pi r square. So shall I use this formula? Yes, yes, to find out the area if you know the steradian angle. Okay, so finally, shall I write here the same point? Yes, good, good, good. Finally, I am writing that point. Why? Because it's already 9:20. So it is the time to wind up the class. Coming to the last point here today. Area of means surface area. Better I write here. Surface area of a part of sphere. Making a solid angle omega at the center is, shall I write, equals to as omega by 4 pi into 4 pi r square. That is simple, like if you cancel 4 pi and 4 pi there, omega into r square. Okay, So in case of two-dimensional circle, arc length is equals to r into theta. In case of three-dimensional, surface area of a part of sphere is equals to r square into omega. Are you able to remember these 2 points? For the two-dimensional circle, for three-dimensional sphere. Arc length, surface area. Yes, exactly. Very good, very good. Right? Now it is the time to stop the class. Okay, shall I stop the class now?